So now that we've understood the history of computing, let's begin looking into uh, how computers actually work internally. Before a computer can calculate anything, before it can display a result, before it can help you send messages, watch videos, or even open an app, it must first receive something. And that something is data. Data is the foundation of all computing. Every every modern system you use today, banks, hospitals, smartphones, websites, etc., all of them begin with data. So what is data? Right. Data is a collection of raw facts and figures that by itself has no clear meaning. Right. So in simple, data is raw facts and figures. And the important phrase here is raw fact. Raw fact. That means the data has not yet been interpreted. It has not been organized, and it has not been processed into something meaningful. Right. Take these examples on the screen: 10, 15, John, 28 degrees Celsius. These are all pieces of data, but by themselves, they don't fully communicate meaning yet. And that's where processing becomes important. Because once data is organized in and interpreted, it can become useful information. More detailed example for better understanding. Hmm. Data is any raw fact, detail, value, observation, or piece of information collected from the world around us. Right? So, piece of information collected from the world around us. Most people hear the word data and immediately think of numbers, but data is actually much bigger than that. Data can be almost anything around you: the music you listen to, the movies you watch, the messages you send, the photos on your phone, the temperature outside, right? Your GPS location, even your voice right now, right? All of these are forms of data. Every click, every likes you do on the social media, every search you do, every video you watch online generates data. And computers are constantly collecting and processing this data every second. So the important thing is that data by itself usually just raw facts, like I said earlier, right? So earlier we learned that data by itself may not have clear meaning, but computers don't just store data, they also process it, and processing is what transforms raw data into something useful. You can think of processing as a computer working on the data. Now, computers perform many kinds of processing, right? So, processing is what's happened when raw data is transformed into something meaningful and useful. A computer takes raw data and then works on it using different operations and instructions, right? So computers perform many kinds of processing, right? But there are four major types you should know. So the first is calculation. This is where the computer performs mathematical operations like addition, subtraction, multiplications, and division, right? Let's say when your calculator gives you an answer, when a bank app calculates your balance, when an online shop totals what do you call it, your items, right? that's calculations processing. That's calculation processing happening, right? Example in real life, calculating your mobile money or your bank balance, shopping totals, or bank transactions. All these are processing, right? So the second type is comparison. This is where computers compare values. For example, is this number greater than another? Are these two passwords the same? Is your balance enough to complete a payment? Right. Computers constantly compare data before making decisions. Right. They compare values to check relationships between them. Right. So example is checking greater than. So these are the comparison it makes: greater than, comparing, less than, equal to, greater than or equal to, not equal to. So example here is 18 greater than 10? True. Is 5 less than 2? False. Right. So in real life, checking if it's like checking if your password is correct, checking if your account balance is enough, comparing your exam scores, right? So these are all the comparing it does, the computer does, right? So the third type is decision making, right? Here, the computer checks a condition and then decide what action to take, right? For example, if your password is correct, access is granted. If it is wrong, access is denied, right? So even apps like YouTube, TikTok, and Netflix use decision making to decide what content to recommend to you, right? The computer can make decisions based on conditions, right? So our example here, if age is greater than or equal to 18, allow access, else deny access. So the computer makes decisions based on conditions, right? In real life, you look at ATM deciding whether to approve a withdrawal, YouTube recommending videos to you, phone unlocking with a correct password or correct PIN, right? The traffic light systems, these are all computers making decisions, right? Good. So let's come to logical branching. That's finally the fourth one. We have logical branching, right? This happens after a decision is made, right? The computer jumps to different instructions depending on the result. If the answer is yes, it follows uh, another path, right? So if the answer is yes, the computer follows one path. If the answer is no, it follows another path. So think of it like a GPS app changing route, right? You reach here in the next 16 meters, take the next left. In the next 4 kilometers, take the next right, right? So it is making decision, right? And then logically giving you guidance, right? Or let's say a game reacting to your choice. So in simple terms, processing is how computers transform raw data into useful instructions, useful actions, result, and information, right? So that's exactly what processing is about, right? Okay. So now we understand what data is, and we also understand processing. But what happens after this has been processed? What happens? That process result is what we call information, right? Information is simply processed data that now has meaning. So before we get information, a data has been processed, organized, or interpreted before it becomes meaningful and useful, right? So information is the data that has been processed, organized, or interpreted so that it becomes meaningful and useful, right? Okay. So let's look at a simple example. Suppose we have the numbers 10 and 15, right? Right now, those numbers are just raw data. But once the computer performs an operation on them, like addition, 10 plus 15, right? The result becomes 25. And now that result has meaning. That meaningful result is information. You understand? So it takes just the raw data, it processes. The processing stage is the adding 10 to 15, right? Then we get information, which is the 25. So the result 25 is meaningful information because the data has been processed, right? Good. Information is not only about numbers, it happens everywhere around us. When Spotify recommends music you may like, that recommendation is information. When YouTube suggests videos, that's information. When Google Maps tells you the fastest route, that's information created from processed data. When a weather app tells you today will be hot, it first processed temperature data, then converted it into meaningful information for you. So in simple terms, data is the raw input, processing is the work done on the data, and information is the meaningful result produced after processing, right? So everyday example, as I said, music streaming, raw data is the songs you listen, processing is apps analyzing your listening habits, right? Information is a recommended playlist for you based on the processing it has done on your listening habits, right? So example two is a social media. Your raw data the system or the computer get from you is likes. Your likes, you like people's pictures, you comment on them and everything, right? You like people's pictures, you comment, you share. So these are raw data that the computer gets from you. So then what? It will process it. So platform analyze this engagement, it will process all these things. Then this post is trending, that's the information based on people's comment, based on people's like the engagement on that particular post, right? So that's how the computer gets information from your social media activities to recommend what you might like, right? So let's take for example school results to raw data your let's say 75, 82, 90. So processing will be average is calculated, like calculating the average of the class. So information you've passed with distinction, right? So this how information is gathered, or this how we get information from raw input. Then it will be processed, then you get your final output so that it will make something that will be meaningful to you, right? Good. So can we say data and information are interchangeable? Okay. First, when we say interchangeable, what do we mean by interchangeable, right? Simply interchangeable simply means two things can switch roles or replace each other depending on the situation. For example, you may use a pen to write and later use a pencil to do the same task, which is the writing. In that situation, they became interchangeable, right? So yes, they can change roles. Data and information are interchangeable. They can change roles, right? So far, we've learned that data is raw fact and information is processed data with meaning. But here is something very important to understand. Data and information can actually change roles, right? What is considered information in one situation can later become data in another situation. It all depends it all depends on what processing is happening next, right? Let's look at a simple classroom example. So let's take the student scores as data. Suppose a teacher has the scores of students in a class, right? 75, 82, 75, 82, 90, and 69. At this stage, these are simply raw values, right? They are piece of data. The computer cannot yet done anything meaningful with them, right? They are just facts collected from student exams. Okay. Now the computer begins processing the scores. It calculates percentage, right? It calculates percentage, organize the results, and prepare meaningful output. This stage is called processing, right? Because the computer is now working on the raw data, right? So this is the raw data. This is a processing stage. It processes it, then information, right? Okay. After processing, the result now have meaning, right? Now we have meaning after processing. We can now understand student performance. So this percentage result becomes information, right? Because the data has now been processed into something useful, right? You can now tell that John had 75%, Doe has 82%, David had 90%, Sarah had 69%. We now have something meaningful or something we can say, oh, we understood. It has meaning now, right? Good. But the story doesn't end there. Suppose the teacher now wants to calculate the overall class average, right? Something interesting happens. The percentage result which were previously information, right, now become data again, right? The percentage result that we have here, which is previously we've seen that it is information. John has 75, Doe, David, and Sarah. Now information becomes data again. The teacher wants class average, right? So this information, we have turned it to a data. It is now data for us that we are coming to use to calculate the class average, right? So now the data is what? The information here is now a data again. So you might be asking why? Because the reason is the computer is about to process them again for a new purpose, right? It's about to process them for again. It's about to process it again for a new process, a new purpose. What's that purpose? Calculating the class average, right? The computer now adds all the percentage marks together and divides them by the total number of students, right? The final result, the final result, that's a 78.5% now becomes new information from the data we have here. The data that was previously information has become data again, and we've used it to calculate the class average, right? This is how we calculated the class average. And then so the percentage is 78.5%, right? It has now becomes a new information because it gives meaningful insight about the overall class performance, right? I hope you are getting it now, how data can become information and vice versa, right? So the important idea to remember in here is this: data can become information, and information can later become data again, right? Information can later become data again. It all depends on what the computer or user is trying to achieve, right? This circle happens everywhere around us, in schools, banks, social media, music apps, and almost every digital system you use today, right? This happens everywhere. The data processing information, information processing new information. Data and information can continuously change, right? It all depends on the situation you are coming to use it, right? In today's world, businesses faces intense uh, competition every single day, right? They face intense competition every day, right? So companies are constantly fighting to attract customers, to increase sales, and to stay ahead of, right? And in a fast moving world like this that we are, making the wrong decision can cost a company money. It can cost them customers and even its position in the market. That is why data and information have become extremely important, right? So if you are wondering why data or the importance of this data and all these things, right? Businesses use them, stock chart moving, employees working on computers, business meeting, online shopping, social media analytics, delivery tracking. Like, we need them every single day, right? Okay. Businesses use data to make decisions. We are looking at an example. So businesses collect huge amount of data every day, right? They collect customers' purchases, website visits, sales records, product views, and many other kinds of data. But collecting data alone is not enough. The real value comes, right? The real value comes when the data is processed into meaningful information, because the information helps businesses make quick and smart decisions, right? Let's look at the second example. Data and information also help businesses. They can track their market trends, customer behavior, pricing change in the market, and new product introduced by competing companies, right? This help organizations respond quickly, right, and remain competitive in the marketplace. So as a business, data is very important for you, right? You have to check. A business will use that data to check uh, business checking competition price. Okay, so sorry about this alphabet. This A here, it doesn't make any sense, right? So sorry about that. So business market trends, customer reaction, social media analytics. So these are the importance of data for businesses, right? So data and information as business assets, right? In modern organizations, data and information are no longer seen as ordinary tools. They are now considered valuable business assets, just like money, right? Buildings, machines, and employees, right, are valuable to a company, right? So money, buildings, computers, data servers, they are important business assets, right? They are very important to the company, right? Data and information are also extremely valuable because they help organizations make proper and timely decisions, right? So, in summary, data and information are extremely important in today's world. They help businesses make decisions, understand customers, track competitors, and respond quickly to changes in markets, right? And that is why modern organizations treat data and information as uh, a valuable asset, because the right information at the right time can completely change the success of business, right? So it's very important to know why you need data in everything you do, right? You need the data, you study it, you process the data into something meaningful, right? So that you get your information. You use data to make better decisions, right? When you have the better decisions, that's when you will see your business succeeding, right? Good. So this is the end of the topic, data and information processing. Data processing and information. I'll end it here. I hope you've understood the difference between data processing and information now, right? So if you like the video, kindly like the video, subscribe to this channel. Let's learn computer science together. I promise to take my time so that I will make things clear for you guys. I will not rush into things. I'm making sure that everything I'm giving you is well understood, right? I want you guys to understand it. I'm just trying to make sure those who are finding it difficult reading a lot of textbooks, PDFs, will find this very helpful in their computer science journey. So see you in the next video. Don't forget to subscribe. Thank you.